All right, looks like people are still rolling in, but I'm just going to do the introduction for a couple minutes, and the meat of the presentation will start with Eric. So I think everyone should be on by then. So thank you everybody for coming. We really appreciate it. I'm Nick Wayne with Cordel, and I'm joined by Eric Henderson, who's our Global Head of Rail Solutions. The purpose of, I'm sorry?
Good morning, everyone.
So the purpose of this meeting is really threefold. We really hope you guys will walk away from this session with, first and foremost, a practical understanding of how to use LiDAR specifically for the 5 use cases that we put on the webinar. So again, that's going to be clearances, ballast, let me go back here, design and construction, road crossing assessments, and more generally virtual site visits. We're hoping that you'll have a sense that LiDAR technology is more approachable and more useful than you previously thought. And hopefully it'll stir some, some creative juices, and you'll have some curiosity about how LiDAR might be used for other applications within the railroad, things that are more, in your personal day-to-day. I do want to point out that this is not a pitch for Cordel. The stuff that Eric's going to be doing, he's going to be using our software, but this really can be done with any point cloud and pretty much any LiDAR software that's available on the market. So the session's about the value of having access to this type of data and what you can do with it in the rail environment. For the agenda, we're going to just do a quick housekeeping. I'll introduce Cordel and Eric. Eric's going to walk through the 5 business cases, and that's going to be the meat of the session. And we're going to leave some time at the end for Q&A. So just to get that piece started, what I'd like to do is start a poll here. There's just one question. It's not mandatory, but it's going to ask you which of these 5 use cases did you come for specifically. If there's any, you can select multiple. If there are other, just select other. And if you don't mind, write those applications in the Q&A. And when we get to the end, if we have time, we're going to be discussing whatever kind of the popular ones are here. So thanks for filling that out. I'm seeing you guys are doing that. So just a little more housekeeping. Q&A, like I said, use that. It's going to be anonymous. So you can type in your questions. I'll have a chance to review them while Eric's talking. If they're super relevant to the point at hand, I may interrupt Eric, but ideally we get through all the 5 use cases, because as this poll is showing, there's people here for everything. So we want to make sure we cover them all. And then at the end, we'll have a discussion. So real quickly on Cordel, so why are we doing this webinar? Background for those of you who aren't familiar with Cordel, we started in Australia. We were doing surveys for railroads, and one of our customers, which is the biggest freight network in Australia, had an issue with their clearances, and they wanted to be able to update their clearance measurements more frequently. So our solution was to put a sensor package, kind of a lightweight, low-cost sensor package on their geometry car, scan the network, and we used automation to process and handle the data, and some AI to do the actual clearance measurements, looking at infringements on the thresholds they gave us. It worked really well, but one of the outputs that was kind of a bonus for them, because they weren't expecting it, was we now had LiDAR point clouds of their entire network. Eric's going to walk through why that's extremely valuable. I think most of you are aware or have a hunch that having that centimeter accurate digital twin would be useful across your organization. So that's how we launched Cordel. Is we had that was about 5 years ago. When I launched in the US about 2 years ago, I reached out to Eric. I knew that he had been doing a lot with LiDAR, GIS, and PTC, and he can explain his experience there. And I said, hey, why doesn't every railroad have this? This should be standard practice. After politely laughing at me, he explained kind of the hurdles of adopting this technology, which he can go into in more detail. But he did explain, listen, this stuff is extremely, extremely helpful for all of my stakeholders around. He was at CSX at the time. Just explained all the applications and use cases that people were finding with this data. So Cordel launched with this purpose of helping railroads access and utilize this data to its full potential, quite simply. The way we do it is listed on the slide there. I won't read those bullet points. So that's kind of the background. That's why Cordel is doing this. We're here in the US. Let us know if you guys have any questions. Our contact info is at the end. And yeah, without further ado, I'm going to pass it over to Eric.
Thanks, Nick. I appreciate it. As Nick mentioned, I'll go ahead and share my screen just to get something to look at. As Nick mentioned, I was previously with a Class 1 railroad, CSX, here on the East Coast, and was there about 14 years. So had quite a bit of experience. I was in the GIS department doing field-based data collection. So I started out, excuse me, I started out when PTC got signed into law. We had to map the entire network. We chose LiDAR to do that, and had a great experience there acquiring all of the information that comes with the LiDAR. And initially, the goal was just to extract assets for PTC. Very quickly, I realized that with that investment in the LiDAR for the entire network, the additional benefits truly became endless. My role in the GIS department, I headed our enterprise GIS team. So my job was to deliver GIS information to the rest of the company. My stakeholders, as Nick mentioned, were virtually every department in the company. And so when they would come to us and say, hey, I've got a road crossing issue, I've got a new construction project coming up, I've got an issue with purchasing ballast for next year, all these different issues that we're going to talk about today, I was able to pull information out of our LiDAR and start to work with these customers and deliver them incredibly valuable information that, we kind of lucked out, right? I say this tongue in cheek, we lucked out with PTC and that we were able to invest in this technology and acquire the information. But with that being said, my goal was to get this information out to as many people as possible. And so I've got many, many years of experience with delivering these over to my customers, right, on the railroad side. And when I came to Cordel, I decided that I really wanted to make sure that when we were pitching LiDAR to our potential customers, that they understood, quite often somebody in the railroad that has interest in LiDAR has one job or one responsibility. They may wear a lot of hats, but they may be interested in one aspect of what the LiDAR can provide. And that's a better way of putting it. We all wear many hats at the roads. But what we're trying to do here is explain that you may buy the LiDAR for clearance assessment. You may get the LiDAR for ballast. What I hope you walk away with is sort of a think outside the box type of idea of, wow, I can use this for a lot of different departments and make it really multifunctional. Okay, so what I'm going to do is just, I've pulled up, we've done quite a bit of work here so far. We've got a handful of collections here in the States. We've got some in Australia and the UK. I want to just kind of describe for you, go with me on an idea or a concept here of these different use cases that I'm going to have. So what I've pulled up here is an example of a construction site. What this was an area of poor drainage, right? So when I was out high railing with our customer, they explained that that they were having some issues with runoff down the hill. They were having some issues with pooling on the side of the track. Water wasn't flowing across the track, and so they were actually pulling up the culvert, putting in a new culvert. So a pretty decent sized job. One of the benefits that you get typically when you have LiDAR is you get this video that, in addition to the LiDAR, really tells the story of what's going on out there in the field. So here you see a standard construction site. I'm just going to stop it right here. Got some materials are already dumped. You've got your construction barricades set up, your snow fence around the equipment. You see two heads, drainage heads on either side with the railing. So get a sense of what's going on here. Now, this is a scene of during construction. So I want you to imagine that prior to going out there and looking at that site to decide how to repair that drainage, imagine if you had a 3D model of that area, right? And so here's that same location. Here are your drainage heads on both sides. Here's that pile of debris. Here's the construction trucks, and the issue with the runoff. LiDAR can be utilized. That 3D model can be utilized in many different ways. So what I've done is selected our 2D profile tool. right? And again, this isn't, as Nick mentioned, the goal here isn't what Cordel has to offer. This is actually a free viewer called Poetry that we incorporate. So these tools are not proprietary. It's just something that we see great benefit in. Take a look at that 2D profile, and very quickly, if you can see down the bottom, I'm following along the slope of that hill up to the right, understanding what the elevations are along one side of the track, transfer over in between the tracks and see my elevations. Over on the left side of my screen, I see an X, Y, and a Z. Tells you my elevation, right? And then on the right-hand side, what does the slope look like over here? So if you're back in the office and you have a report from the field of drainage issues, there's lots of different things that you'd be able to do. You could also change that 3D profile and look along the track to see what direction that water's draining in. Taking a look at the Z value. Now let's start to think, well, I've identified an issue and I'm going to need to export this. I've got a construction company, a vendor, a third-party vendor that wants to come out. Any of these cross sections here can be exported and sent in a CSV file or a LAS file. Those are industry standard file formats that third-party civil engineering firms could easily receive and now get a real good sense of what's going on. Not only your cross section, but you can also export this entire LAS file, right, and send that off. So now think about when you do have those issues and you reach out to your civil engineering firms and they say, okay, we're going to have to come out and do a site survey. I've heard anywhere, I've helped write those requests for civil engineers. I used to work for one prior to the railroad, and they could be anywhere from $5,000 to $50,000. Imagine you have this LAS file paid for once and are able to deliver this to them and eliminate that cost, right, of doing a pre-construction site survey. Now think about, we're in the middle of that survey, we're in the middle of that construction project, right, and we've happened to come through here and do a LiDAR scan. Now, in this case, the goal was to do periodic, whether it's quarterly or biannually or annual scans. But if you've got something like LiDAR that's very light and portable, you may want to come out and do runs if you're going to be in a construction phase that may last 2 months, it may last 6 months, right? If you're adding a double or a third main or extending a siding, it could be 6 months to a year. There's nothing stopping you from coming out and doing periodic LiDAR runs to assess what the conditions are looking like during construction. Another great function of the LiDAR is being able to get volumes, right? So this is a neat little tool that allows you, maybe you want to figure out, you've got some construction debris left over, or there's an issue of delivery, right? We ordered X number of tons of dirt and the project manager on site doesn't think that they got the order, right? And so you can come in here and take a look. Down the bottom, I've got a live volumetric count that as I assess that pile that was dumped, right, my volumes over here immediately change. And so again, no need to go out and create sort of an estimate by eye, but this 3D pile is, again, your virtual twin of what's out there. So these types of things can be done and measured without ever leaving the desk and have extremely accurate measurements, right, as opposed to an estimate of what's been dumped. Now let's, perhaps say this is construction is complete, and I know in this case these were the head walls prior to the drainage, but maybe you want to go out and assess, post drainage. Again, I go back to my 2D profile tool. I'm going to go right underneath those head walls and come back up along the right of way on the other side. Now I have a complete picture to understand if rain is going to fall and pool in this area, right? What direction is it going to flow? Where's the low-lying area? Are we going to make it underneath those tracks? And then what is the elevation on the other side? And compared to, the direction of the water flow on both sides of the track. You could always take that and extend up the hill and get another sense of where's that drainage going to come from. So imagine all this information that you'd be able to do. And I drag and drop that dot. I know it, might not be the exact scenario, but you can just imagine that, hey, we're sitting down in a conference room and we're doing post-construction, and we want to just sit here and really tear this site apart and decide to get everything in there that we want. There's just an incredible amount of information to plug and play. It's not a one-time static report, right? It's kind of what I'm getting at, that there's a lot of information that can be ascertained and And if questions are asked, you can manipulate these profiles here to try and get whatever answer you're looking for. So that's just a one example of what how design and construction could utilize this information. Next thing I want to look at, we're going to talk about sort of what we always call the bread and butter. I'm just going to pull my screen over real quick and set to my next location. What a lot of us talk about when the bread and butter of LiDAR, I always say is clearances, right? Clearance, a lot of lines, a lot of rails actually get an income stream from moving high and wide materials on their roads, and so clearances are incredibly important to them. Along with moving high and wides, the downfall of clearance issues is vegetation, right? So both we're looking at structural vegetation as well as structural clearances as well as vegetation clearances. So what you're looking at here is an example of some clearance infringements that we have found. This was a customer that wanted to see, they gave us an envelope and said, could you tell me, and something along the lines of 12 feet wide, 12 feet high, right? Let me know where you see clearance infringements. So in this case, we've got a little bit of brush along the lines. You see this red here in the point cloud that indicates something is inside of that envelope, right? So as I click through these infringements, you see a little bit more. I want to grab some of the overheads that really tells a better story. So I'm going to look a little further down here. There we go. I'll pull up one overhead. So what you're looking at is a 2D cross section of the LiDAR. And I'll jump to the LiDAR here in a second, the live view of the LiDAR, but this is one method that you can use your LiDAR for. What we do is we take cross sections along that track. Now, when we're looking at clearance, again, whether it's vegetation or structural, it doesn't really matter, right? If something is going to hit inside your envelope, you want to be aware of it. Now, how you take action is up to you, right? In this case, you've got some leaves that may or may not be brushing the track, and it may be a very slow track speed out there, so there may not be a concern. You may choose that on your end, that this is minor and we'll address it later in the year when perhaps that grows more. Or if this were crossbucks or a cantilever or a bridge, you'll see here in a minute, something you can't wait to, you have to take action immediately. So this 2D cross section allows you to cut that LiDAR point cloud into cross sections and then pass that envelope, whether it be 12 by 12, 10 by 10, or an AAR plate. So perhaps that your line is clear for plate G or plate D. You can pass that plate through your LiDAR profile and identify these areas where action may need to be taken. Over here, as we follow down out to the bridge, I'll show you an example of what the clearances look like. So here's an example of a bridge. And if I were to take a look at that clearance infringement, now I will say in this case, we wanted to demonstrate some clearance issues, right? So I'm very pleased to say they did not have clearance infringements on every single girder in that bridge. This was an example where we over exaggerated that plate in order to facilitate showing what the clearances would look like. This green is obviously, as we're passing through the bridge, the green is clear. The yellow is that warning zone, and the red is an area that would strike. And so that again allows you to sort of assess that clearance infringement as well, to say, hey, I've got green through here, but I've got an area of yellow, something I need to keep an eye on. And then anywhere where you would potentially see a red would be a strike, and so you would have to take action. And so that nice pattern is each one of those girders. You've got a swing bridge here that I'll show you. Each one of these was a strike on that, that we demonstrated inside that bridge. So now let's say we do see that issue came up where I believe that there was a strike inside. Now we've got the 3D model of that bridge and can go in and assess where I've just drawn a a measurement line here to show you what that looks like. But you now have that 3D bridge right here in front of you and can do any type of measurements that you want inside that bridge and try and figure out if there is potentially a pipe that came loose, right? Maybe you've got a utility line, a water line running through here and something came loose. Maybe you've got an issue up at the top. This was a swing bridge in this instance. So again, anytime you put this bridge in motion time after time, you run the risk of things coming loose. And so that ability to sit here and look at those clearances is very valuable. That I'm not going to go out and take a measuring tape every single time, but as I go through, I can push that same plate through every time and get a better understanding of what's going on in this bridge and seeing if anything is coming loose. Now, maybe a bolt is wiggling out and gets inside that yellow envelope, not something that's actually necessarily going to strike, but if you catch it in that yellow area, that warning zone of that infringement, it's something that you can take action on before it gets into that red, right, and causes catastrophic failure and potentially strikes the train. So there's the multi-directional measure tool that allows you to sort of pull that virtual tape measure between any 2 points. There is also a vertical measure that allows you to come in and grab from the bottom and go straight down in any direction, right? So this is always going to force me, as I rotate around, force me to go directly down from that girder. So now I can see what the measurement is to the top of the rail. I can see what directly straight down is. I can see possibly what this platform, if you've got a walkway, what that measurement is from the top. So again, just having all these tools available to you, it's not a sense that you're getting a one-time report or something like that. You actually have a live dynamic, real world tool that you can go in and take a look at and get a better understanding of what type of issues might be going on out there. So those are some clearance issues that we found both in vegetation and in structural in the bridge. Another thing that we found great value in is for one of our customers is in now generating reports for ballast, right? So what I want to explain and talk a little bit about ballast is the idea that what I'm going to describe to you here is an area in one of our customers in Australia where we have started classifying our point clouds. So I want to describe what you're seeing. In this specific use case, our customer was concerned about capital planning for next year for buying ballast. So the areas that you've seen, what we needed from them was we needed them to tell us, well, what is your engineering standard for ballast, right? So they gave us the slope that they wanted to see in both the top of the top of the ballast line as well as on the shoulders that you see here. Where is it? The ballast batter. As I turn our ballast batter on and off, you'll see that shoulder there. So we've got the orange on top and we've got the red ballast batter on the sides. What you're looking at then in the yellow is where we found deficiencies based on their standard, okay? So I can now turn on and off and flash for you where those deficiencies are. So you may look at that and think, well, that's great, but I'm not going to go out there and necessarily start filling potholes, right? These are tiny little areas where I see deficiencies in the ballast, but I'm looking at something on the grader, on the 5 mile, 10 mile, 20-mile section. I want to know the entire line. How many tons of ballast do I need? And do I need it this year? Or is it okay comparatively to my other lines? Can I wait till next year? So what we do is, well, this looks like it's, I call it the pothole finder, right? But while it may look like we're finding tiny increments, what we then do is quantify the results of what you're seeing in those deficiencies in a simple CSV report. So this is something, again, that where you're taking the basic LiDAR deliverable, but you're also generating quantifiable results from it. So what you see here, in this case, our customer wanted 20-meter sections. They wanted the information broken down in 20-meter sections. So you've got a lat-long location of that section, and you've got a northing and easting for your local coordinate zone. And then you have a max width, which tells me how wide was that deficiency, as well as a volume. Now, again, you may look at that and say, well, 0.62 cubic meters, right? That doesn't mean anything to me. If it, here in the States, we'd give you a cubic foot volume, right? That's one pothole is deficient by 0.62. Not a lot of help. But what is a lot of help is then you take this entire line, right, and sum it up. And now you start to understand in that entire section of track, this might be a 1 mile, maybe a 10-mile section. You can now clump those together, right, and get a total deficiency of volume. So now if my question is whether I'm ordering 1 million, 2 million, 3 million metric tons of ballast, how much am I actually deficient on that line, and what am I really going to use? Well, this type of reporting is, relatively speaking, right, in its infancy. So, we haven't been doing this for 20 years. Nobody has, using LiDAR to quantify these. I challenge you this to think about how could you interpret that report and slice and dice that report differently, right? In this case, we're telling you left batter, right batter. So where on which side of the track are those deficiencies, or center, right? If there is any discrepancies, deficiencies in the center. So the information can be broken down. Again, the standard, you may look at this and think, let's minimize that. You may look at that and think, well, I want to know further out, right? That's a simple change of the standard. Add a couple extra feet to both sides. Find out, maybe you want to come back and say, I want to come back and add more ballast. Next year, I want to change my standard. So if we ran that same line with a different standard, you'd get a different amount of deficiency. So you would know how much ballast do I need to add in order to get up to that same level. I will add here one of the nice byproducts that we've had from our ballast assessment tool is the identification of the road crossings. So we now know where not to, again, ballast is you're not going to find ballast in your road crossings. And so we've identified all the crossings. We now know start and end of the crossings. So we're getting into, not going to talk about it here today, but we're getting into PTC asset identification through the manipulation of each one of these areas in LiDAR. We're able to discover these types of things. And so now we know, in this case, in the ballast case, we have no dump zones, right? And so we'll now be able to identify where to dump and not dump, and we can report that back for you. Next thing I want to talk about is road crossings. So one of the surprises that I had, again, I spent many years delivering the LiDAR information to our business partners. And, initially I thought the biggest consumer was going to be engineering, right? I always thought engineering and PTC, being an asset heavy organization, I thought those would be our heaviest hitters. But what I found was that our legal department, as soon as I started reaching out and getting questions from our legal department about, do you have information? Unfortunately, we had a crossing incident that occurred, and we're being asked for existing conditions. That was something that happened, unfortunately, more often than not. And we quite often came across those questions from legal. And so when I started going over and showing them the LiDAR, it was an incredible response for them to understand the entire picture of what was going on. So I'm just pulling up for you real quick. I'll go ahead and pull it back now. Pulling up an area that has a road crossing here. And the sort of narrative that I want you all to think about here, as we drove through the road crossing, you'll see a car on both sides. So it really helps us to understand, from a legal perspective and a safety perspective, what did the road crossing look like? So imagine you've got a line of road and you get the unfortunate call, in the morning that something happened overnight, and you've got a team of lawyers, you've got the safety department, you've got the engineering folks, maybe the FRA crossing team. All these people are looking into what occurred at that location. There's always the zoom to Google and take a look at what's there, but in this case, imagine if everybody could gather around and be looking at this type of information where you can very, very quickly assess what are the conditions that are out on that road, right? Do we have crossbucks? Do we have gates? What's the line of sight look like? So in this situation, I have one of the benefits of LiDAR is you can change the view of that LiDAR. So in this case here, what I'm doing is looking at that LiDAR by elevation, right? So I'm color coding each one of these individual points by their elevation. And I can adjust that elevation here with the slider to sort of help tell the story of what's going on out there. You know, seeing where the high points and low points are. And as I slide that, you can start to see some of these areas out there actually pop and get a better understanding of what's on the ground. One of the other things we can do is look at the intensity gradient, right? Now, I like this when I'm looking at road crossings because there's a lot of different things to see in that crossing. What intensity gradient is doing is, as we're traveling down that track and those lasers are firing and rotating around, right? Each time that laser returns, and you see here as I zoom in, right, you see this striping pattern. Every single one of those dots is a laser return back to the scanner. And that scanner records how strong that laser returns to it. So hard objects are going to return with this really bright red color. So of course the reflectivity on the back of that crossbuck means that laser returned extremely hard. Off of the steel, you'll see a great return. Off of the ties in the crossing, you'll see a return. There's probably some reflectivity on the front of that car. So nice, you get to see a little bit better view of what that crossing looks like. So what I want to demonstrate here is, let's say we had an issue where, you know, line of sight was in question at that road crossing, and you have, you know, the legal team and the safety team are trying to figure out, you know, what was available to be seen by the public. So I'm going to go in here and you can see the front end of the car. This is a great example because if you can imagine I'm a passenger, I'm approaching these crossbucks. What I'm going to do is grab my measure tool, right, and look at the front of that car and try to assess where I can see down that line. So we've got a whole bunch of trees here. My line of sight, right, about 350 feet, 370. Now what I want to do is demonstrate what you can do with LiDAR is actually remove those trees and see. What I'm going to do is flip back to elevation, kind of help me see those trees a little bit better. And now I want to use this tool, the clip tool. And what this clip tool is going to do for me is allow me to go in and highlight those trees as if I were going to remove them. And I'll pull that down. And this takes a little bit of getting used to. And I know I've had some people say, well, gosh, I'm struggling. You know, I can't figure out, thing keeps twisting around on me. All I'll say is, you know, stop and think what Google Earth was like when we first got in, and it was something new to us, and we didn't really have an understanding of exactly how to use it. But the more we use that tool now, you know, I use it every day. So I don't want people to be intimidated. You can see I just sort of quickly came up and manipulated that box, grabbing those colors. This isn't something that needs an intense amount of training. But what I can now do is remove those trees right from my view. Here it is with the trees in my view, and here it is removed. And now I have a better idea of exactly, if I were to go in and remove those trees, what would my new line of sight be? Now, whether this actual situation is, you know, is useful as far as I can't just go in and clear cut Farmer Joe's, you know, property here. But what I want you to understand is this type of information is available now. This type of functionality is available, right? Again, back to that 3D model of your world. Imagine you want to go in and if you're going to remove a building, maybe you've got some line of sight issues in a yard, and you've got some sheds, you've got a signal house, right? If you had a signal house here and there was an issue of line of sight around the signal house, you could simply remove that signal house. Maybe you want to go in and assess, a third-party vendor that went in and did some construction for that exact fact. Utilizing that tool allows you to remove those trees. I can come back and remove anything else in here, any of those other signal houses or that type of thing. Even a bridge, right? Coming around a bridge, if we were going to widen and add another main through there in a curve, that type of situation, you could do that and maneuver those. Another example that I just want to talk about in the road crossing. Again, I hate bringing it up, right? But it's the inevitable. We do have issues that occur at road crossings with the public. I had done a demonstration for our legal team. I had gone out and trained one of our field investigators in using this information for his site investigations. And he had gotten called out the night before a presentation to our legal team. He had gotten called out in the middle of the night, had to go assess a road crossing. And what he had explained in our meeting was that typically when he showed up on site, now imagine it's the middle of the night. In this case, he told me it was about 3 a.m. before he got on site. And he normally would have taken anywhere from 3 to 6 hours to go out there with a tape measure, a flashlight, a GPS device, possibly clipboard, laptop, you name it, right? Camera to document the location, to go in and recreate the scene for what would be a potential, legal or safety evaluation of what occurred at that location. Now, what he said was he pulled up in his truck, opened up our LiDAR, and had a situation like this where he had every single structure out there in the field already measured. I'll flip back to that intensity gradient. He was able to skip having to go through and measure where all of the crossbucks were, the lengths of the gates, the width of the crossing, where the stop line was on the ground, because he was able to see it in the LiDAR. And it was actually a much more complex location than this that he was able to describe. But what he didn't have to do was then identify, while there's overhead wires and there's trees and there's a bridge and all these different factors that would have played into what could have gone wrong with that public crossing. Said he saved himself hours and hours of work that night by only having to show up and identify where the public vehicle was and where the engine was in that 3D point cloud. And so again, and he also mentioned, had I gone out there and done it in the middle of the night, I probably would have missed some things. I would have had very round or generic, the engine ended up over 1,200 feet away. He was able to come into the point cloud and identify where it was in the point cloud and not have to walk the 1,200 feet. So, more and more examples where he had a much better picture that he was able to deliver back to the, for his accident scene recreation based on utilizing this LiDAR. So that's another example of where, we use that LiDAR, collect once, measure as many times as you want, right? So kind of the opposite of the measure one, measure twice, cut once. Here you measure once, right? Do your collection once. And the number of times that you can reuse this information is endless. My last example I want to talk about, and this is sort of a catch-all bucket, and that is the benefit of site visits, right? The virtual site visits. Now, when I say virtual site visit, think about, each one of these cases that I've talked about, the clearance, the vegetation, the ballast. In none of these situations that I have to go out in the field, right? I'm sitting here in the comfort of my office, at a desk talking to all of you guys, doing these measurements, getting this information, able to export this information, right, and deliver it to lawyers, to civil engineers, to GIS folks, to capital planning, purchasing folks, to understand how many tons of ballast. None of these things that I have to go out in the field and assess. Now, I do have, imagery to support these claims. I do have video. I do have aerial imagery. In this case, what I'm going to describe is this site right here. You never have to eliminate the need to go back out into the field, right? But a lot of this information I can handle and do these site visits from my desk and obtain a lot of this information before having to go out. Or when I go out, I forget to collect something, right? Oh, I forgot to look that direction, or I forgot to go over behind this building, right? None of that becomes a problem anymore because I always have this model here for me. So I took a look at this location. And again, I'm kind of pulling from my experience of in the past, I'd always been asked these questions. Hey, we've got a new customer that was online many years ago, but they've shut down, and a new customer has purchased the property and wants to come in and restart service. So zoom in and take a look, and you can see here we've got an old couple of old grain elevators here, an old processing facility, and you've got some tracks that have been torn up, but you can see evidence that they were there, and they go under the bridge. So let's just pretend that this customer has reached out and contacted us and said, hey, we'd like to put in some new tracks. We'd like to expand. Can you help us, right? What's available to us? So without even going out into the field, right? I'm able to come in here and see what those old tracks look like. I see that they've been torn up. Here's the main track through that we surveyed on, and I can see that the steel may or may not still be in place in some locations, but certainly not to the condition where we can start running trains again. So what I want to do is figure out, well, if I want to rebuild and get underneath this bridge, now maybe they come in and say they're going to be bringing in some oversized cars, or that they want some storage tracks, along our main. And so they want to add a second or a third set of storage tracks. Well, without having to go out and start doing a complete assessment, I have the ability here to come in and see where were the old tracks. Right. And do we have room underneath that bridge to get in another set of tracks, right? What's the height elevation underneath this track, underneath this bridge, right? Do I have any restrictions if they're going to bring in some oversized cars, maybe for construction purposes, right? They're going to bring in some equipment by rail and they want to know what their clearances are. I can figure that out right here without having to go back out there. Maybe they come out and decide, hey, we want to put our tracks. Maybe we want the tracks to lead in the other direction. We're going to be delivering, off here to the east, maybe not to the west. I went in here and took a look and found there's a small bridge and a small creek just to the east of this customer, right? So now I know, well, if I'm going to bring my tracks over this way and add another couple of side tracks here for the customer, I now have this bridge to contend with, right? And maybe they want to know, well, not afraid of a bridge. We're willing to put this in. It's going to be a high profitable customer, but I want to know, how big is the bridge? What's the damage going to be if we're going to go in there and widen this bridge? Do we have the potential to do that? I go right back here to my profile tool, right? And now I can understand, we've already demonstrated the profile tool before. I can come in and find, I can find out what the drainage looks like underneath that bridge. There we go. And I can quickly assess the top of rail. I can come back and change those dimensions and see what's down underneath the bridge. And I can export all that information to a design vendor. Right. So imagine all of these different things, different criteria. You get a first pass at a customer reaching out and saying, hey, is this even possible? All this information that I'm able to do and learn and say, well, go ahead, heading in this one direction, we do have a bridge there. These are the dimensions. This would be the challenge of if you wanted to bring in oversized cars. In the other direction, we do have this bridge here. I'm taking a look and seeing what type of structure it is. Maybe we send this over to our bridge department and get them to assess what would it take to, add an additional track on the side here. We need to have some type of method of maintenance of construction along the way. We're going to build a temporary bridge, or we're going to build a secondary bridge here, tear the first one down. All those kind of things could be done without ever having to go out and contact a civil engineer, do a complete site survey, and then begin, assessing what we can do for that customer. All that information could be done right here in that LiDAR point cloud. Again, back to that, I measured once and now have this information, at my disposal. So there's just, a handful of ideas of things that can be done, for your, for your company to be able to get the most benefit out of your LiDAR. What I want to say is now let's backtrack, right? So you're watching all these use cases and you're considering whether LiDAR could be right for you. What I found to be very advantageous we collected for PTC in my past position, we collected one time for PTC, and then the follow-up collections, right, and adding more equipment to our tool belt and getting more scans done, we're very easily able to prove that value by getting all this other support, getting these other departments, right? So legal alone is not going to pay for a scan of 10,000 miles or 20,000 miles, right? Most likely when they're only needing a handful of road crossings. Same might be true for ballast, same might be true for clearance. I don't know. That's going to depend on your road and the size of your road and your customers that are there in your rail. But if you go through, right, if you're considering doing this and you want to go and get those other stakeholders, we're more than willing to walk through these different scenarios and cater an entire demonstration to legal. I've got, for each one of these incidences, unfortunately, I've got a dozen more incidences over the years where legal was able to, utilize this information. We were able to pick up fence lines for illegal, illegal crossings for utilities coming across the line. We were able to find fiber poles in the woods. We were able to find fences that encroached on our property. We were able to find illegal dump piles of ties or dirt or tires or whatever it may be, all for legal. And these types of things will only help that use case where you don't want to be stuck paying for a one-time, scan of the network and you're only using it for yourself. You want to garner as much support as you can, and you can do that by bringing in these other stakeholders. The other benefit is again, the flexibility of having this tool in a web-based application. Again, that allows you don't have to go to your lawyers, your safety team, your design and construction, have them install all new software and go through IT and getting that approval. You can use it now in a web tool and deliver them a username and give them immediate access. So just some more things to think about when deciding whether LiDAR might be right for you is, the accessibility to it. Can I find what I want and share it easily? So we've reached the 10-minute mark. I'm gonna, Nick, and ask you if, invite you in if there's any questions that you've seen from the group, or if anyone has any that they'd like to put in the Q&A section. I'm happy to kind of start answering those.
I've got a few for you, Eric.
Sure.
I am just a couple more housekeeping things, and then let's have a discussion. I am gonna send out a recording of this webinar along with the 2 intro slides, and then 1 takeaway slide, which is gonna summarize some of the stuff that we've talked about. Just action items. If you need more information or curious about any of this, it'll have Eric's email address and mine. And we're also gonna be at ARIMA in Denver at the end of the month. So come see us if you want to talk there. We'll be sharing a booth with Holland, our partner. So one piece to mention there is the scans that you see here were collected from a different variety of vehicles. Some were on the railroad's geometry car, others were on high rails. And for other customers, Holland will go out when they're doing their track testing and carry our LiDAR scanner with them. So they're not, we're not taking additional track time to get that LiDAR scan. So that's the relationship with Holland and why we're with them at ARIMA. Okay, so to the questions, Eric, I'm going to try to mush 3 questions into one because they're kind of related. It's about, I'm not going to ask you for numbers on precision and accuracy, but conceptually, one of the questions was about, it looked like some of the point clouds had higher quality or were denser than the others.
Yes.
And I know why. Do you know why?
I do know why. So there's 2 main factors that are at play here. One, and I'll use this example here. So we ran this scan gosh, about a year and a half ago with our old sensor that was a Quanergy 8 sensor. What that means is there were 8 lasers inside the puck rotating as we drove down the track. Those 8 sensors are painting these 8 lines as we travel down the track. And we have since upgraded to a HESI 32 puck, which now rotates 32 lasers. So as I zoom in, you see 32 laser patterns as we travel down the track. So one factor that plays into the density of your LiDAR is how many lasers you're actually firing as you're traveling down the track. The second factor is definitely speed. So if you're traveling at 5 miles an hour in a high rail, going extremely slow, imagine, running a paint gun or a squirt gun or something out the window as you travel at 5 miles an hour. You're going to hit a lot of things, right? That laser scanning is going to get a lot of hits and a lot of returns. Now, fast forward, you decide to put it on a geometry car that maybe runs track speed. Some track speeds could be, 59, 69, even 70 miles an hour. So the difference of what you're going to hit with those rotating lasers, if you're traveling at track speed on a rail car, definitely plays into the spray of the pattern. So I quite often get asked the question, how many 100,000 dots per square inch, right? Does it hit? It very much depends on your speed and the number of lasers. So to speak to the accuracy of the laser in relative terms, so the laser, without taking into GPS into consideration and absolute location, the relative location, the relative accuracy, which is within the point cloud itself, how accurate is the distance between these two rails? That's very much dependent on the spec sheet of the manufacturer, right? So the reason I say that is we incorporated in this scan a HESI 32 laser, and their spec sheet states, a few centimeters of accuracy. So what I try to do is point people to the direction of the manufacturer specs. I've been in the field collecting data for 15 years and working with GPS, and unfortunately it's always, and it depends, right? It depends on GPS quality. If you're asking about absolute accuracy, always depends on the satellites in the sky that day and what you post-processed against. So in relative accuracy terms, you can rely on the manufacturer's spec, but and then also the speed. So hopefully that answers.
Yeah, thanks, Eric. And the next question kind of ties into where you left off, which is, in your experience, at what point, and I'm guessing this depends on the railroad and the project, right? But do you need, instead of having this track-based LiDAR, that we're doing, do you need to hire or do a professional survey and have a certified, extremely accurate point cloud? And where's the cutoff? Is it a different type of project? Is it based on, what is, in your experience, the
Sure. So what I've and great question, right? One of the things that I kind of like about my experience with the railroad is we're moving dirt and laying steel, right, for a train to run over. What we're typically not doing, right? I don't want to speak to, we're not typically building buildings and bridges. Now we are building bridges out there, and those are very much rely on very strict engineering standards as we're holding the weight. But majority of the work that we've been able to do, putting in switches, adding new customer tracks, right, is all based on ground elevations and distances and those types of things that are extremely accurate in this situation. So what I will say is, I'm not a civil engineer or a professional engineer, right? I don't have my stamp. I don't have my PLS stamp, but the information that I've been able to provide to our design and construction engineers, as they've said, is incredibly invaluable for having this, this entire site laid out. If you were to go contract a surveyor to assess every single structure that you see here, it would take weeks and weeks and tens and hundreds of thousands of dollars, right, to paint this 3D model of everything. If you're coming in trying to do a site layout and understand where am I going to put tracks and where am I going to add more dirt, it's more than sufficient, right, to do those types of things. Now, with that being said, quite often I might have a civil engineer come back to me and say, yeah, but you know what, I need to know the exact dimensions of this structure. I need to know, I need to be able to stamp it for the local municipality. perfectly fine, right? But what that PE or surveyors now only has to do is go out and ask for a very small portion of what they originally would have needed to do an entire site design. If you're doing bridge construction, you may need, you know, a signed stamp PLS survey. You can still go out and do that, but having all of this ancillary information makes that request for that survey a much, much smaller cost and project size. What else you got, Nick?
So we got time for one more. There's some that are fairly technical that I don't think we'll have time for, so we'll follow up with those folks. There's one that's knowing you, it might take a minute, but what is your, you know, it sounds like there's dozens of things you can do with this. Is there a slam dunk virtual site visit application? Forget the automated clearances and ballast and the other stuff that we've been looking at. Is there one that's just kind of foolproof?
I'm going to go back to my legal examples. I'm so unfortunate that there are many examples that I could talk about. What I saw the great benefit from was being able to paint an entire picture of a site and have it extremely accurate, have a date and time stamp on when that information was taken, have measurements available, and be able to provide that information to lawyers who are going to show a judge or show a jury. And it's not measurements in a spreadsheet. It's not measurements on a whiteboard, right? It's a 3D picture that tells what did the information look like. I can't tell you how many times I was called after producing this information by one of our lawyers who was ecstatic and said, God, the judge dismissed the case, or you know, the plaintiff dropped their charges, that this wasn't big enough, that wasn't wide enough, because we had this information available to us. So, you know, being that I was with a Class 1 railroad, we unfortunately, with 20,000 miles in 23 states, we came across that information all the time, or those situations all the time. And I just got such a response from our legal and safety teams for our ability to paint that picture in an extremely accurate manner. That was always a surprise to me at how well we were able to do that and get good results.
Cool. Well, we are right on the hour. I want to thank everybody for coming. Eric, any final thoughts?
Yeah, I saw one. I got to admit, I saw one question in the Q&A that I had an easy answer for that I just wanted to address, if you don't mind. The question came: if you have I ever integrated GIS information into the point cloud and any issues? So yes, we did integrate. I have previously integrated GIS information into the point cloud, and yes, I did have issues. The challenge is finding, so in the situation of mileposts, right? If you get a lat long coordinate for your milepost, perhaps your elevation might not have an elevation for it, right? So if you try to integrate information that's not three-dimensional into the three-dimensional world, you're going to drop, you know, your information is going to come in down at 0, right? So again, this whole point cloud is a 3D model, and it's floating up in the air at, you know, 1,200 feet above sea level. So if I put in information, GIS information that has a 0Z, it's going to come in way down here at the bottom. Now, with that being said, okay, great. Well, I do have a Z value for my information. If anybody's ever collected GPS information, they know the Z is the worst value, right? It's the least accurate value because elevation is just so hard to get with it. So I would very often try to bring in GIS information, and my mileposts were floating up here in the air or sunk down below the actual ground. And it just became a challenge. The same was true for track center line. It seems easy, like, well, you know, I've assessed this track center line and I'm at, you know, 1,200 feet, and my track center, my GIS information that I surveyed is 1,200 feet. Even the slightest deviation is going to look extremely weird when you come in here, and there's, you know, the method by which the two were collected. When you try to overlay them, it's very hard to get them to line up. With that being said, you can always come in and use this tool to, let's just say this is a milepost. I snap to that milepost. Now I see my elevation at 309, and I can fix that value in my database, right? And now I know exactly. So now when I bring that 3D model back in, that 3D information back in, it's going to land exactly on one of those laser points. So just wanted to touch on that real quick because it's, it's been asked and worked on that before. So hopefully that helped, Dan. Nick, no, to your point of wrapping up, I hope everybody gets a good idea that there's many use cases. Don't ever hesitate to reach out and ask, hey, I got this request. Can LiDAR help solve this? I would love to talk through it with you, and hopefully you're thinking outside the box of different ways and different people to bring in and take a look at your point clouds. And we're here to help, and hopefully you got something out of it. Do you want me to, Nick, do you want to put up your screen?
I mean, I don't think we need to. I'll just send out the material, everyone. Probably going to take a day or two. I'm going to try to put this on YouTube and bookmark where the different use cases start. So see how I go with that. But thanks again for coming. You should get an email in the next day or two with the recording and the slides. And we hope to see everybody in Denver. And like Eric said, feel free to reach out anytime. You've got our emails. Thanks.
Great. Thanks so much, everyone.